In this video, I'm going to show you how to set up a model that represents this situation where we have two constant head boundaries representing streams, and the stream along the bottom, initially it's at a head of 0, and it raises to the head of 1 at time greater than 0, and we create a pressure wave that moves from bottom to top. So we start off with a blank model. It's a 2D model that uses Darcy's law, and in this case it'll be a transient study, time dependent. And so the geometry that we'll select is a rectangle that's 1,000 by 1,000. If we go to the physics, we select the rectangle, and we'll go in here and specify the boundary conditions. We'll have two hydraulic head boundary conditions. So we click on Darcy's law and then right click to get this selection, and we press hydraulic head twice. The upper boundary we select, and that will be specified as a hydraulic head of 0. The lower boundary we select, and that's a hydraulic head of 1. Now we also have to specify the storage model. That allows us to include the property of specific storage that we need to simulate a transient model. So we put in the density of water, change to hydraulic conductivity. We put in hydraulic conductivity of 1e to the -6, and storage we go to user defined, and this is a specific storage that we'll use as 1e to the -8 per Pascal. The mesh is a default mesh for now. And the study, we expand this, we see that it's a time-dependent model, and right here the time that the model will run starts at 0 and goes to 1, and so that's going to be too short. These are in units of seconds, so we want to change that. And if we go to from 0 to say 3e to the 7th, and we have say 30 values over that interval, then we can use those time steps like so, and we run the model by clicking equals. Okay, so there's the solution, and we want to take a look at the results in terms of hydraulic head. And so to do that, we'll expand this and select, this is pressure, what is shown right here. So we'll select Darcy's law, hydraulic head, and replot it as the pressure. The pressure goes from 1 at the bottom to 0 at the top. That's great. That's what we expect. Okay, so let's draw the cross-section. Go and put in the data set as a cut line from x equals 200 to y equals 0 to x equals 200, y equals 1,000. So there's the line. And just to make keeping track of this line a little bit easier, I'm going to click here and I'm going to rename it. Cut line 2D1, that's somewhat cryptic. So I'm going to call this cross section 1. Now, to plot these results as a function of time, I go to Results and right-click, include a 1D plot group, and then I right-click again and select Line Graph, and then I go to cross-section 1, now appears here, so I select that, and go to hydraulic head, and then I can plot it here. So there's the hydraulic head at the 30 different times that we've selected here in the study. We also created a video, and so I can do that by going to Reports, to Export, sorry. The player is selected here, and you can see that the default is to use this 2D plot that I've created here, and that'll be good. That's what we want. Although we could change it. We could select a different plot. We could go and do the 1D plot if we wanted. But let's do the 2D plot, and we've selected all the different times here. That'll work for what we want at this point. We select, we press that. That creates the video file, and then we can press this to play it, and we can see how it moves with time. One thing we can do too is slide this back and forth to see how the results change as a function of time. The time is right here. So this is a very simple problem, but for more complicated problems, this can be a very nice way to play the transient response and diagnose what's happening.